Hello everyone. Back to Engineering Hub case studies. Now we transformed the case study to be an AI-powered research and development platform, basically. So instead of just doing a case study, it can do a feasibility study, an R&D, and a proposal. Now today we're going to stress test it. Basically, currently we have community studies. If somebody generates a case study from the other side, it was implemented around in April, I think. uh, you can get it there, so you can just come here, open up a project yenye mtu alifanya kitambo, and then you'll be able just to see it and interact with it. Now today we are going to be a bit crazy with what we're going to do. It's not going to be something normal. We're just going to stress test the R&D platform. Now we're going to do something so dumb and yet conceptually good, like AI optimized autonomous medical drone network for Nairobi County. In our dreams, Anyway, let us just look at that. And then the description is this: design a scalable drone delivery system for emergency medical supplies across Nairobi County, including blah blah blah. So it's an R&D. Now this is I don't know, electrical. I think it's cross discipline. No. This is an electrical thing. Now we're going to do the electrical thing here, and then just start R&D exploration. Now we wait for it to work. Sounds fun. Now this is the hypothesis engine. It is familiar. Now you might think that this is just something we put there just to keep you, but it's actually doing it in real time, like searching for Google, searching Google for real time data, research question, found 35 sources for research question, researching state of art, blah blah blah. Yeah, it is telling you, it is giving you the agent log. So instead of just looking at these, you can just come here and check at the agent log. You see what is happening directly in the background. This will help you not stay idle or just do something else. So we can just wait. Probably in the normal video, we will have forwarded this stage. But and I love how this thing goes. I love how this thing uh, moves. It gives you, it doesn't keep you idle. Now you have to know that we have used 237 sources in a span of say 5 minutes. If you are doing this research on your own, my friend, you will strongly defend one source because you are very lazy, so you won't care about the sources. Now, yeah, this is the R&D. This is what it has generated. AI optimized autonomous medical drone network, and this is the research question and hypothesis. How can an AI integrated beyond visual line of sight drone network be architected to achieve a 95% reduction in emergency delivery latency compared to motorcycle dispatch within the high density urban and peri-urban environment of Nairobi County while maintaining whatever that is electrical safety and 99.99% communication reliability? Now, as you know, I'm not a nerd, and now I am not going to go through all these things. This is very nerdy. But if you want it, if you come to the case studies page, you'll find it and you'll be able to interact with it. Now let us check other sections. Yeah, it's talking about loads of stuff here. It's just that I don't understand. Uh, wow. Yeah. Let us try and scroll down again. Okay. So how it? Yeah. Uh-huh. Innovation opportunities. Who is innovative? I'm not. High alt density compensation. Okay, I don't know. Do some people really understand these things? Okay, standard on C charge to ensure confidence, whatever that is. And this graph, I know a motorcycle and I know a medical drone. I don't know what the percentage means. Resource requirements. Wow. Uh-huh. Mm, I'm equally as shocked. Who came up with this? Now, expected outcomes. Wow. What is even this? I can do something with it. Oh, wow. I never knew that. Now, impact assessment, final, then the interactive lab. Now, the interactive lab. Woo! This is the real-time pathfinding and latency simulation. I just have to say wow. No? Wow. Woo! 36 units. Have you seen the UFO videos? It looks like that UFO that was being rumored to become to be an angel or something, yeah? Payload, nice floor. I don't know what is this? Wind velocity, blah blah blah. What is it even doing now? The sensitivity engine is here. Now people will understand this thing. I know me and you we don't, but some people understand what is going on. We will let the people who understand what is going on understand what is going on. But for people who don't understand what is going on, you can just come and ask this AI here to explain in layman's terms. Layman's. What the hell is going on? Now let's see if it also knows what is going on. 237 sources. Can you imagine? Now this thing is saying that it's continuing. Relax, my man. I don't want all this information. Come on, it's layman's. Why are you giving me all this? Okay. Let us just read the first sentence, paragraph. Imagine Nairobi County, a busy place with lots of traffic, getting emergency medicals. I know that. This project is about designing a futuristic system. I know that. The main goal is to see if these AI drones can deliver supplies 95% faster than motorcycles. Okay, so that if that was the main goal, what is the conclusion? In short, this is a plan to build. Uh, yeah, I think first we predict a 92 to 96% reduction in delivery. Okay, this is the expected outcome based on the study. Okay, I think yeah. So I'll just you can export to PDF if you want to start to read this thing. I for one I don't want to read it. So yeah, it is added here. So you can just come and yeah, do your stuff.